everyone, and thank you for tuning in to the NASA SpaceX Crew-8 mission, a long-duration rotational mission to the International Space Station for NASA astronauts Matthew Dominic, Michael Barrett, Jeanette Epps, and Alexander Gurbenkin. I'm Jesse Anderson, a manufacturing engineering manager here at SpaceX, and I'm joined by NASA's Sandra Jones. We are just under a couple hours away from the final approach and docking of Dragon to the International Space Station, and the crew is awake and ready to monitor the final steps.
That's right, Jesse, and we have had a couple of major milestones leading up to docking already, including a few burns, and we are expecting another to begin in just a couple of minutes right now. That is called the approach initiation burn, and this helps to swing Dragon up and in front of the International Space Station ahead of docking. We are expecting that docking in a little less than an hour and a half this evening. Everything is going really smoothly so far. The crew is actually a little ahead of the timeline, which is always great to hear. At this time, they are awake and getting ready for docking. They are suited up in their spacesuits. They remained suited all the way through docking and during the dynamic phases of flight. The crew launched yesterday evening at 10:53 p.m. Eastern from the Kennedy Space Center in Florida, and since then they have been continuing their way to the International Space Station ever since. And we are hearing the call out that that approach initiation burn has begun. It's about a 90-second burn, so we'll listen in for those call outs. But again, everything going really smoothly so far. The crew is ahead of the timeline, and I'm sure looking forward to arriving.
Dragon SpaceX on Dragon to ground. AI burn was nominal. I'd also like an update from you guys on suiting status.
Copy, nominal AI burn. We're about to put the first suit on.
Copy, first suit about to go on.
And we did actually hear that the crew is now getting suited up following that approach initiation burn that was successful. So they'll have these spacesuits on throughout the remainder of the trip to the International Space Station all the way through docking. So we'll hear some more call outs about that suit up progress. But for now, let's look back at yesterday when the crew launched. 3 of the Crew-8 members are flying for the very first time. So launch day preparations started early yesterday for our crew members. About 4 hours prior to launch, the crew completed their final medical checks before joining the SpaceX team to get into their spacesuits. After suit up in the NASA operations and checkout building, the crew walked out, waved some final farewells to their family and friends who were waiting outside, and the next destination for the crew was the launch pad. It was about a 20-minute Tesla ride to pad 39A, where the Falcon 9 and Dragon spacecraft were waiting for them. 2.5 hours prior to launch, the crew ingressed or entered the Crew Dragon spacecraft, walking over that crew access arm and enjoyed some last views of the Space Coast, heading into the White Room and into the spacecraft.
At 7:53 p.m. Pacific Time or 10:53 p.m. Eastern Time, the 9 Merlin 1D engines ignited and Falcon 9 lifted off from Space Launch Complex 39A, marking the 13th time humans rode Dragon into orbit. With Falcon 9's first stage at full power, our crew began their journey to the International Space Station. Just after T+9 minutes, the first stage landed at landing zone 1, and a couple minutes after that, we had spacecraft separation where we saw Dragon finally flying free.
And about 45 minutes after liftoff at 8:39 p.m. Pacific, Dragon executed the phase burn. This is the first of 5 major burns required to raise Dragon's orbit and position it for approach to the International Space Station. Dragon raised its orbit using the Draco thrusters over the last several hours as it chased down the space station.
And just a few hours ago, the boost burn took place at 4:12 p.m. Pacific Time. The boost burn put our crew in an orbit where Dragon's apogee, or the highest point, will be 10 kilometers lower than the station. After that, we executed the close co-elliptic burn at 4:54 p.m. Pacific Time. The close burn placed Dragon on an orbit roughly co-elliptic with the space station, meaning it was maintaining an orbit roughly 10 kilometers lower than the station the entire way around the Earth. That's in contrast to only being 10 kilometers lower than the station during Dragon's apogee, or the highest point in its orbit, which is achieved by the boost burn.
From there, at 6:44 p.m. Pacific, we executed the 4th major maneuver known as the transfer burn. This is where we're raising Dragon's apogee, or highest point of its orbit, to just 2.5 kilometers lower than space station. Then we rounded everything out with a final co-elliptic burn at 7:31 p.m. Pacific to once again maintain a constant orbit lower than the space station, this time just 2.5 kilometers below. This was a shorter burn lasting just over 30 seconds.
During the approach, SpaceX flight controllers will work in tandem with the NASA team in Houston to maneuver Dragon Endeavour to the proper attitude. They will initialize the navigation sensors used for the methodical approach to station. They'll also activate and test out a number of systems on Dragon, including bidirectional communications with the station using the C2V2 system. C2V2 stands for Common Communications for Visiting Vehicles. It sets up a data stream from Dragon to the station, giving another path for Dragon telemetry to come to the ground and giving an additional command capability to astronauts aboard the station.
At approximately 10:03 p.m. Pacific, Draco thrusters on Dragon will fire for the approach. Well, this actually just happened, right? We just had the approach initiation burn here just a couple of minutes ago, and all of that went really smoothly. It helped to swing Dragon about 2.5 kilometers below space station and just about 7 kilometers behind it. And eventually, it will help us get to 400 meters directly below the space station. This maneuver also moves Dragon inside one of 2 checkpoints around the station that requires a set of go, no-go poles with the different control teams. That first checkpoint is called the approach ellipsoid, or as you might hear it called, the AE. It's an imaginary shape measuring 4 kilometers by 2 kilometers by 2 kilometers and is essentially a 3-dimensional oval. Before Dragon is given permission to move inside that approach ellipsoid, the capsule is configured to be on what is known as a 24-hour safe trajectory, which means that if Dragon lost all control to its thrusters, it would be at least 24 hours before its trajectory would move inside the approach ellipsoid.
The NASA and SpaceX teams will do a go-no-go poll to move Dragon inside of the keep-out sphere, another checkpoint that consists of an imaginary sphere around the station with a radius of 200 meters. Flight controllers use this to monitor all arriving and departing vehicles. This is another chance to confirm all the guidance, navigation, and control systems are working correctly on Dragon before moving closer to station. It carries a similar requirement on the orbital trajectory that if Dragon were to somehow lose control of its thrusters it and the space station would be safe for 4 orbits, or about 6 hours, rather than the 24 hours required to enter the approach ellipsoid. Once Dragon arrives at 400 meters below station, it will be at what is known as waypoint 0 and will be the first checkpoint during our approach. The vehicle can hold here at 400 meters, but if all of its systems check out, it can continue to approach to waypoint 1.
Dragon's move from waypoint 0 to waypoint 1 will swing it up and out in front of the space station, arriving at a distance of approximately 220 meters. At this point, it will be on what is called the docking axis, which essentially means it is directly in front of the docking port. The crew are headed to the forwardmost port on the space station, which is called the Node 2 forward and is the Earth-facing port. Dragon has docked to Node 2, also known as Harmony, for all the crewed missions so far because that's where both international docking adapters are located and installed for new commercial spacecraft flights as well as any other future spacecraft that use the international docking standard.
Once Dragon is only 20 meters away at waypoint 2, the spacecraft focuses on aligning its docking system with the international docking adapter. We may hear the call-out CHOP, which stands for Crew Hands-Off Point, a little less than 30 seconds before docking. At this point, any aborts will have to be done automatically by Dragon.
And then it will be the time we have been eagerly anticipating, the grand arrival when our crew arrives at the space station. We are targeting that contact at 11:28 a.m. Pacific. 11:28 p.m. Pacific, and Dragon will fly in and make contact with the IDA, giving us what we call soft capture. The soft capture ring then retracts until sensors indicate it's time for 12 hooks to drive in place to give us a hard capture and firmly secure Dragon to its new home on the space station. From there, the station crew, namely NASA astronaut Jasmine Mogbelli, will manually pressurize the vestibule, or the area between the Dragon hatch and the station hatch. Meanwhile, umbilicals that provide power, audio, and data connections from the station to Dragon are put in place. Then it's time for leak checks, hatch opening, which is currently timelined to come a little more than 2 hours following docking.
Now, as we continue to count down to docking, let's take a closer look at the Dragon spacecraft that took Crew-8, that is taking Crew-8 to the International Space Station today. The Dragon spacecraft and its trunk stand over 26 feet tall. There are 2 windows on the spacecraft, plus 1 under the nose cone. The nose cone opens shortly after launch to expose the forward bulkhead thrusters and docking mechanism that will connect with the space station. Dragon's trunk holds solar cells, which power Dragon while it's in free flight, and the trunk can also carry unpressurized cargo.
Dragon has 16 Draco thrusters that can be used in space to help navigate the spacecraft to its destination. Each provides about 90 pounds of force, but that doesn't include the 8 Super Draco thrusters used for an abort, which are no longer active once the crew is in orbit.
And for those of you following along, you'll know that the Dragon spacecraft has played a significant role in advancing our future in space by safely transporting crew to and from the International Space Station. There are currently 4 Dragon spacecraft supporting human spaceflight missions that have docked to the station. That's Endeavour, Resilience, Endurance, and Freedom.
As you saw in the video, Crew-8 are on board Endeavour, which previously flew NASA's SpaceX Demo Mission 2, Crew-2, and Crew-6, in addition to AX-1, the first commercial astronaut mission to the space station. Altogether, the reusable Dragon spacecraft has completed 7 human spaceflight missions on behalf of NASA and visited the station 38 times under NASA's commercial resupply and commercial crew programs.
Over the last 23 years, crews aboard the space station have completed thousands of scientific and educational experiments, and Crew-8 is prepared to add to that growing number. Crew-8 will conduct hundreds of science experiments and technology demonstrations during their mission. They will spend several months working in our orbital laboratory. Having more crew members on board significantly expands the amount of research that can be conducted. This crew will conduct new scientific research to prepare for human exploration beyond low Earth orbit and benefit humanity on Earth. Experiments include stem cells to create organoid models to study degenerative diseases, studying the effects of microgravity and UV radiation on plants at a cellular level, and testing whether wearing pressure cuffs on the legs could prevent fluid shifts and reduce health problems in astronauts.
These are just a few of the more than 200 scientific experiments and technology demonstrations taking place during Crew-8's mission. During their mission, the crew will perform dozens of investigations sponsored by the ISS National Laboratory. These projects span a wide range of disciplines, from life and physical sciences to advanced materials, technology development, in-space production applications, and even student-led research. Results from these studies will bring value to humanity, furthering our ability to explore and enabling a robust. Matthew Dominic, who hails from Wheat Ridge, Colorado, and is married to Faith Dominic and has 2 daughters. Matthew earned a Master of Science in Systems Engineering from the Naval Postgraduate School, and he was designated as a naval aviator in 2007 and reported to Strike Fighter Squadron 106. He made 2 deployments to the North Arabian Sea, flying close air support missions in support of Operation Enduring Freedom, and he has accumulated more than 1,600 flight hours in 28 aircraft models, 400 career arrestments, and 61 combat missions. In 2015, he was awarded Naval Test Wing Atlantic Test Pilot of the Year, and this is his very first space flight.
Dr. Michael R. Barrett, Crew-8 pilot, was selected by NASA in 2000. Board certified in internal and aerospace medicine, he participated in 2 space flights, Expedition 19 and 20 in 2009 and STS 133 in 2011, during which he spent a total of 212 days in space. He received his Doctor of Medicine from Northwestern University and completed his residency and master's program in aerospace medicine at Wright State University. In 2011, he was awarded the prestigious Hubertus Strughold Award for contributions to space medicine research. Michael lives in League City, Texas, with his wife, Michelle, and their 5 children.
And this is mission specialist Jeanette Epps, and it's her first space flight. She's also a NASA astronaut. The New York native was a NASA fellow during graduate school and worked for Ford Motor Company, where she received a U.S. patent for her research. After leaving Ford, she joined the Central Intelligence Agency, yes, the CIA, for 7 years, working as a technical intelligence officer before becoming an astronaut in 2009. Dr. Epps served as a representative to the Generic Joint Operation Panel working on crew efficiency on the space station, and she was a crew support astronaut for 2 expeditions and served as lead Capcom, or capsule communicator, in Mission Control Houston. Dr. Epps was inducted into the University of Maryland Department of Aerospace Engineering Academy of Distinguished Alumni in 2012.
And another first-time flyer, mission specialist Alexander Grabenkin earned a technical diploma in technical operation of transport radio electronics from the Irkutsk Military Aerospace Engineering Institute in 2002. He also has an engineering degree in radio communications, broadcasting, and television. In 2018, he was accepted in the Cosmonaut Corps and began general space training at the Yuri Gagarin Cosmonaut Training Center.
Everything we learn on space station enables our technology, it increases our knowledge, and it burns down our risk as we go further.
As explorers, we're looking at ways to further human knowledge, human experience.
Как сказал однажды Константин Эдуардович Циолковский, наша Земля — это колыбель человечества. Но не может человечество все время оставаться в колыбели. Поэтому именно за счет того, что мы нарабатываем сейчас пилотируемыми полетами.
People are so different on Earth. The more people we get into space, the more things we learn about what happens to their body in space, the more we learn to move humanity further to the moon and then ultimately to Mars.
The experiments that we'll conduct help with radiation, how to grow plants in space, how to get the human body to last longer outside of Earth's protection.
In zero gravity, we've actually discovered physiological processes, how the body works, that we didn't even know existed without finding them first in space. That includes mechanisms to lower your blood volume to adapt to a weightless environment, mechanisms that store sodium in your body, which we didn't know existed, ways that the human can control its cardiovascular system that we didn't know existed.
Every single human that's ever been born and ever died has all happened on our planet Earth. And if we want to continue the light of consciousness further, we need to make ourselves multiplanetary.
Just since we're about 30 minutes ahead of schedule, just wanted to point out the shutter constraints and the exercise constraints. Those will all be going to the left.
And our mission will definitely contribute to that.
Good morning and welcome to the International Space Station Flight Control Room at the Johnson Space Center in Houston, Texas. We are gearing up for this morning's docking and looking forward to having Crew-8 on board station here soon. But before the crew can come aboard, Endeavour will complete its docking and hatch opening operations. NASA astronaut Jasmine Mogbelli will be in the station's cupola using special software to track Dragon's approach and making sure it stays in the expected zones. Once Dragon is docked, Mogbelli will be primed to start hatch opening operations. She'll start by opening a large hatch on node 2 forward to give her access to the pressurized mating adapter. The crew will then have to pressurize the vestibule, which is a small space between the hatches on the Dragon and the space station. This area was exposed to vacuum prior to docking, so the crew will need to fill it with air and make sure the pressure is nearly equal with atmospheric pressure on Dragon and the station. Mogbelli will use a small valve on the station's hatch to slowly introduce air into the station's vestibule, and flight controllers here in Houston will monitor and verify the pressure readings to make sure everything is leak-free before we open up the hatches. NASA Flight Director Paul Kanya is leading teams here in Mission Control Houston for Dragon's approach and docking, and to their right is Capcom, or capsule communicator, Neil Nagata, who will be communicating with the crew aboard station. Right now, there are 7 astronauts aboard the space station, and that number will jump to 11 once Crew-8 astronauts arrive on board. Again, we're excited to get our Crew-8 astronauts aboard to work on handover with the Crew-7 astronauts, and that's the latest here from Mission Control Houston. Back over to Hawthorne.
Thanks, Anna. So glad to hear that everything is continuing smoothly from the International Space Station side, and we are looking forward to that docking coming up at 11:28 p.m. Pacific time this evening. So the crew on board the International Space Station is currently in their post-sleep period, but following that, they're going to jump right into those docking preparations that Anna was telling us about. Jasmine Mogbelli is going to be prime for all of that vestibule work that Anna just talked through. So we should be seeing her start to get some tools set up and really prepare for Dragon's approach and docking.
We are about 10 minutes away from the next milestone coming up, which will be waypoint 0. And that's when the vehicle is getting closer and closer to the space station. And there's a few...
Station Houston, expect to start monitoring Dragon in approximately 35 minutes.
And you can see on your screen a pretty incredible view. This is Dragon looking at the International Space Station, which is where it will be docked for about the next 6 months. So very exciting. You could tell that we're getting closer and closer as the view there is very visible from the Dragon spacecraft.
That's right, and the International Space Station is currently flying 268 statute miles over the South Pacific Ocean. But yeah, we'll continue to see the International Space Station come into better and better view. You can see some of the solar arrays and some of the modules, but again, I'm looking forward to seeing it come into more detail and us sharing a bit more about what you're seeing on your screen. And you can see if you squint between the clouds there, that little white dot, that is Dragon with Crew-8 on board. We'll, again, continue to see and this new crew. Oh, and there's an even better view. You can see the nose cone is open there. That nose cone did open shortly after launch, and it stays open all the way through docking. It exposes that guidance, navigation, and control systems. And that's actually where the crew will enter into the International Space Station once we get docked and have the vestibule repressurized and all those checkouts go smoothly.
Copy, Mike. Successful intercom checks. For awareness on timeline, we will have you step into suit leak check after the approach 0 burn is complete.
Copy. Suit leak checks after approach 0.
And so Endeavour is now 435 meters from the International Space Station, closing in on waypoint 0. You do hear some communications from the ground up to the crew just to let them know they're going to wait for this burn to complete before they begin those suit leak checks. The crew is in those spacesuits and will remain in them through docking, but first they're going to complete some leak checks just to make sure that everything is as it should be. In case there were a depressurization scenario, the crew would be able to be A-OK in those spacesuits.
And again, as we approach these different checkpoints, waypoint 0, waypoint 1, waypoint 2, they're actually just checkpoints. The vehicle will be monitoring its position, and if everything checks out, it can just continue to make its way to the next
SpaceX
checkpoint.
Dragon to ground, complete with 4.010.
Copy. Suit donning procedure complete.
And we are less than 1 minute until waypoint 0.
And Dragon, with that, I would like to bring cameras back on board.
And SpaceX Dragon, you are good to come on board. Welcome.
And with that, we do expect to get our first views on board Endeavour here shortly.
The suit's primary function is to protect the crew in the event of a cabin depressurization. If that were to occur, the suit would inflate and provide a habitable environment long enough for the crew to return home. The flame-resistant materials on the outer layer also protect the crew in the event of a fire. And these are custom-tailored suits to each one of these astronauts. They are a single-piece suit. This means that the helmet, gloves, and boots all remain attached. The helmet is actually made of 3D printed nylon and has a visor that pivots open, which you may see when we see the crew when they open and close their visors. The quick disconnect, or QD, on the right thigh mates to an umbilical on the seat. This is what provides the air ventilation, oxygen, nitrox for pressurization, and allows the electronics to be connected all from a single location on the suit. A tubing network inside of the suit also delivers air to the neck and limbs to keep the crew cool while wearing the suit, because it is, covering them, probably keeping them a bit warm, so the air flowing through helps keep them cool. The suit's communication system consists of helmet...
Dragon SpaceX on the big loop. Approach 0 is in progress, and trajectory has converged on waypoint 0. Arrival at waypoint 0 at approximately 1711. And with that, you are good to proceed into 4.011 for leak checks.
Dragon copy, stepping into 4.011, suit leak check.
And good calls there. They have confirmed that we have made it to waypoint 0 and that the crew is good to perform their suit leak checks inside of the cabin there.
And Crew-8 has passed through waypoint 0, which is that 400-meter checkpoint below space station. Right now, it looks like they're about 381 meters away from the International Space Station. So as we begin to move closer to waypoint 1, which is our next milestone, a couple of things are going to happen. The sensors on Dragon are going to work to basically get a lock on the docking port that it's targeting. And once they do eventually dock, that soft capture ring will automatically capture the docking port, and then we will work to close those latches.
Dragon on the big group, ready to pressurize.
Dragon SpaceX, you are go to initiate suit leak checks.
Copy to go.
And there you heard some comms that they are beginning their suit leak checks. Again, they do put their suits on during the dynamic events of docking, so they are doing some suit leak checks to make sure everything is working properly with their suits before they dock to the International Space Station. So they are pressurizing those suits right now inside of Dragon. They'll do this leak check and then make sure that everything is good, and if so, then they can proceed towards docking to the International Space Station.
All the different time zones across the world, but on board the International Space Station, they use GMT, which is Greenwich Mean Time, and that helps everyone stay on the same time across the world, 24 hours a day, 7 days a week, 365 days a year. Team members there are trained in a variety of disciplines and monitor all of space station systems. Just like Mission Control in Hawthorne, we have someone dedicated to talk to the crew members to streamline communications. This keeps the astronauts from needing multiple conversations on different subjects. This role is called the CAPCOM, which stands for Capsule.
Just some good comms there. Just a reminder that when Dragon reaches waypoint 2, it will pause to align with the docking system, but then we'll continue to move forward with approaching the International Space Station.
And so at this time, we are within that keep-out sphere, which is a 200-meter radius. It's an invisible line around the International Space Station. This keep-out sphere means that if something were to happen with Dragon, there would be a 4-orbit safe while outside of that. But again, everything's continuing to go really smoothly. The next major milestone that we'll see is about 20 meters from the space station when we'll arrive at waypoint 2. And at this point, Dragon will focus on aligning its docking system with the IDA on the space station's commanded attitude. And once we get to waypoint 2, it's usually about a 5-minute period before we have contact and capture. So coming up on waypoint 2 arrival here shortly.
The view that you're seeing on your screen is a view inside of Dragon Endeavour with the commander on the left-hand side, pilot on your right-hand side, and they're just monitoring those displays there. Again, Dragon is an autonomous vehicle. They do have the ability to take over manual control if necessary, but you may hear a call out for CHOP, that is the crew hands-off period. And that's when
and the crew aboard
Station
the
Houston on the
Dragon
big
Endeavour
loop.
spacecraft.
Dragon is on final approach and is go for docking. Monitor for steps 5 and 6 in 1.102. Dragon approach and retreat monitoring.
Station copies monitoring for steps 5 and 6 of Dragon approach and retreat monitoring.
And we just heard good words that NASA astronaut Jasmine Mogbelli, who's currently aboard the International Space Station in the station's cupola monitoring docking, is good for docking to proceed, and the Dragon crew aboard Endeavour has their visors down and are prepared for the final approach and docking in just a few minutes from now. Again, everything is continuing to look good here on the station side. And the voice you heard of NASA astronaut Jasmine Mogbelli, who will be in the station's cupola, she'll be using special software to track Dragon's approach and ensuring the vehicle stays in the expected zones. And then she will also be primed for hatch opening operations once Dragon is docked. During these operations, she'll start by opening the large hatch on Node 2 forward, giving her access into the pressurized mating adapter. The crew will then pressurize the vestibule, which is the small space between the hatches on the Dragon and space station. This area was previously exposed to vacuum prior to docking, so the crew will need to fill it with air and ensure that its pressure is nearly equal with the atmospheric pressure on both Dragon and space station. Mogbelli will use a small valve on the station's hatch to slowly introduce air into the station's vestibule. Flight controllers here in Houston will monitor and verify the pressure readings to make sure everything is leak-free before we get ready to open up the hatches. The entire process will take a couple of hours to complete. We're still on track for a docking in just a few minutes, followed by a hatch opening a couple hours following that, and then we will round it all out with a welcome ceremony as Crew-8 officially joins the Expedition 70 crew currently aboard the International Space Station. Again, everything continuing to proceed smoothly from here in Mission Control Houston. Back over to Hawthorne.
Thanks so much, Anna. Great to hear that everything is going smoothly from the Mission Control Houston side. We are getting a view right now from Node 2 forward or from Harmony where Dragon is slowly coming in to dock to the International Space Station. Right now, Dragon is about 22 meters away. And so soon we may hear that call out for CHOP, which is crew hands-off period. From this point, everything will be automated and the crew will not have to do anything. If there is some type of situation that comes up, Dragon's computers would handle that from that point. So we are just about 20 meters away from capture.
And once Dragon does make a soft capture to the International Space Station, there's still a few things that the vehicle needs to do to make sure that it does complete a hard capture. Following the soft capture ring will retract until the sensors indicate that it's time for the hooks to drive in place. And there's 2 sets of hooks. There will be 6 to start. followed by another 6. And once those hooks are in place, then it can attach its umbilical, and that will conclude the hard capture for Dragon. So even once Dragon approaches the International Space Station, there are still a few events that do need to happen to confirm that hard capture.
Meters.
Copy, 15 meters.
So you did hear that call out that Dragon is now less than 15 meters away from the International Space Station, continuing to close in slowly. We'll hear that call out for CHOP, crew hands off point 2 meters before contact. Now approaching 10 meters away from the International Space Station.
Meters.
Copy, 5 meters.
Should hear the call out for CHOP shortly.
Meters.
Copy, 2 meters and hands off.
And there was that call. Standing by for contact and capture.
1 meter.
Copy, 1 meter. Soft capture confirmed.
And contact confirmed. Dragon made contact with the International Space Station at 11:28 p.m. Pacific while flying central over the North Atlantic Ocean just east of Newfoundland.
And there are still a few steps to complete before Dragon is securely attached to the station. Again, we do have soft capture, but then we will retract that soft capture ring. Then we can start driving in the hard capture hooks. Again, there will be 2 sets of 6 hooks each. Once those hooks...
Ring retraction in progress.
There's that call out that the soft capture ring is now being retracted. And then shortly we should hear that the first 6 hooks will begin to drive in for that hard capture.
And so if you are just joining us, we did have Crew-8 successfully docked to the International Space Station just a minute ago at 11:28 p.m. Pacific time. On board Crew-8 are 4 astronauts, and there you can see a view of Endeavour docked to the International Space Station. That's the forward port of Harmony. On board Dragon are 3 first-time flyers and 1 veteran NASA astronaut. And so Dragon will remain docked to the International Space Station throughout their mission. They are targeting a 6-month-long mission aboard the International Space Station.
Now, it does take a few minutes for that soft capture ring retraction to complete, and then it will take another few minutes for hard capture with the 12 hooks that will drive into the International Space Station to hard dock to the International Space Station. We should expect that soft capture ring retraction completion in just a couple minutes from now.
And once soft capture is complete, we will have those hard capture rings you were talking about begin to engage. There's 12 of them in total, but they'll engage in 2 groups of 6. So the first 6 will engage, and then the other 6 will engage. And at that point, we'll have a successful hard capture docking.
There will also be an umbilical that does attach from Dragon to the International Space Station. So while Dragon does have its own internal battery power, while it's docked to the station, it will connect with the International Space Station's power.
That's right, and you do see the nose cone, which is open there at the very front of your screen. Now that you see it docked, it makes a lot of sense why it needs to be open so that all that guidance and navigation control system can be exposed. But again, this is the hatch that the crew will actually float through once they go aboard the International Space Station after that vestibule is pressurized and all those leak checks are completed. So that won't happen right away. It is a bit of a process, but we will be providing coverage throughout that. So stick with us, and then you'll be able to see the crew float aboard the International Space Station for the first time. Another thing to point out here is that on the
And there we can see Crew-8 being joyfully welcomed aboard the International Space Station. First aboard was NASA astronaut Matthew Dominic, followed behind him NASA astronaut Michael Barrett and NASA astronaut Jeanette Epps. And pulling up the end, we have Roscosmos cosmonaut Alexander Gurbenkin. The Crew-8 astronauts now officially a part of Expedition 70, and the other Expedition 70 crew members giving them hugs and handshakes as they make their way onto the International Space Station, which will be their home for the next 6 months as they conduct important science and research. With Crew-8 officially on board, we're now just standing by for some welcoming remarks from the crew. And we are currently in a brief but expected handover period. We will get signal back shortly and get those views back of the International Space Station crew.